Hi students, welcome to the class. Dear students, today we are going to learn the new lesson that is called as rational numbers. Dear students, in the previous year classes we are studied the whole number, natural numbers and then integers, and also rational number is also studied in the 7th standard, correct? Yes, this year we are going to study rational numbers. Before going to the rational numbers, we have to recall once again the whole number, natural numbers and integers, etc. So students, first of all I will take the natural number. Natural number, they represented the letter N. Natural number means the counting numbers are called as natural numbers, 1, 2, 3, 4, etc. up to infinity, that is called as counting numbers, therefore it is called as natural numbers. Then whole number represented the letter W. This that containing natural numbers along with 0 is called as whole numbers. So every natural number are a whole number, but every whole number are not a natural number except 0, correct? Next one, integers. Integers means, see students, a set containing positive integers and negative integers along with 0, that is called as integers. Integers represent the letter I or Z. I or Z. Therefore, a set containing positive integers and the negative integers along with 0, that is called as integers. See here, the right side of the integers is called as positive integers, right side of the 0, and left side of the 0 is negative integers. So now we are going to the next rational numbers. Rational number represented the letter Q. So rational numbers means a number is in the form of P by Q. A number is in the form of P by Q, where P and Q are any integers. Whether it is a positive integers or negative integers, but the condition is very important. Q is not equal to 0. That means denominator not become 0. If it is numerator is become 0, no problem, but denominator is not become 0. Therefore, then the number is called as rational numbers. So, for example, 1 by 2. See here, 1 is the P and 2 is the Q. Numerator and denominator. So 1 by 2 minus 3 by 5, and then 7. Only 7 is it a rational numbers? Yes, because nothing is there means 1 is there in the denominator. Therefore, 7 is also a rational numbers. Therefore, basically 7 is what? Natural number or whole number. Every natural number is also a rational. Every natural number is also a rational number. Every whole number is also a rational number. For example, minus 5. Minus 5 is basically what? Yes, negative integers. Basically integers. So, is it a rational numbers? Yes, it is also a rational numbers. Nothing is there means 1 is there. Therefore, every negative integer or positive, every integer is also called as rational numbers. And then 0. 0 is it a rational numbers? Yes, nothing is there means 1. But 0 is basically what? 0 is basically whole number. Every whole number is also a rational numbers. Therefore, 0 by 1 is a rational number. But 1 by 0, is it a whole number? Is it a whole number? No, it is not an. Is it a rational numbers? No, it is not a rational number, because here denominator is equal to 0, but our condition is the Q is not equal to 0, but here Q is equal to 0. Therefore, 1 by 0 is not a rational numbers. Understand? So next one, 3.5 student. 3.5 is basically what? 3.5 is basically a decimal. Is it a rational numbers? Yes, it is also rational number. Like how? So 3.5 can be written as 35 by 10. Can I write 35 by 10? The decimal form, it is a fraction form, 35 by 10. So 35 by 10 is a P by Q form. Therefore, every decimal number is also a rational numbers. Next students, 3 by 2 is basically what? First of all, 3 by 2 is basically, we are learned in the 5th, 4th standard or 6th standard, 7th standard. We learned the, what is that? Fractions, correct. So fractions and also a rational numbers, are they equal? Are they same? No. So little different is there. 3 by 2 is a fraction basically, but it is a what? Rational numbers. See here, minus 3 by 2. Minus 3 by 2 is only the rational number, but not a fraction, because fraction having always positive sign, but rational numbers not like that. rational numbers, it having a positive integer, positive sign and negative sign. Both sign it is having a positive sign and the negative sign of the rational numbers. But fractions, it having only that positive sign. Okay, that's why every fractions are a rational number, but every rational numbers are not a fractions. Every rational number are not a fractions. Understand? So like this we are discussing that. Understood? So shall we go to the next concept? Yes. Now these are basic points of this chapters. So next one, what? Properties. Properties of rational numbers. Properties of rational numbers. So first of all, I will take whole numbers. Whole numbers, natural numbers and rational numbers. Okay, see students, not natural numbers, integers I will take. So whole number and the natural numbers are included in the whole numbers. So properties, the first property is called as closure property. Closure property. So what do you mean about closure property? Closure property of whole numbers and integers and rational numbers. Okay. So we are discussing all these numbers of these properties. So closure property means you can take any two elements. You have to do any one of the operations that the resultant number it become a resultant number is become a what? Or either whole number or integers or rational numbers. So for example, I will take whole number. So under addition, first addition I will take it. Okay. Here 3 belongs to one of the whole number. 5 is also belongs to one of the whole number. This is symbol is belongs to. Okay. So 3 one of the whole number and 5 is also one of the whole number. So these two whole number we have to do what? Addition. So 3 plus 5. What it become? 3 plus 5 it become 8. This resultant number is also belongs to a whole number. Then it is called as closure property. Understand? Therefore, closure property of a whole number satisfied under addition. Because of 3 and 5 is a whole number, I will add it and then resultant number is also become a whole number. Therefore, it is satisfied under addition. Next one, like that integers. Is it satisfied under addition or not? Closure property. So minus 3 is one of the integers and then plus 2 is one of the integers. Now minus 3 plus into plus 2. So minus 3 plus 2 it become minus 1. So it belongs to integers. Therefore all integers, the closure property of integer is satisfied under additions because of minus 3 is one of the integers and 2 is also another integers. So when you do addition, it become minus 1. This minus 1 is also becoming integers. Therefore, the closure property satisfied under integers under additions. And then rational numbers. So rational numbers, one of the example 1 by 3 plus of 4 by 3. 1 by 3 and 4 by 3. 1 by 3 is one of the rational number. 4 by 3 is the another rational numbers. So I will do the additions. It become denominator are same. So add the numerator. 4 plus 1 it become 5 by 5 by 3 is belongs to a rational number. Therefore, closure property is satisfied under additions of the rational numbers. Understand? Here whole number is also satisfied, integer is also satisfied, and rational number is also satisfied. So all are satisfied. And the next step, subtraction. Subtraction, see students, 9 is one of the whole number and 5 is another whole number. So I will subtract it. It become 9 minus of 5 it become what? 4. It belongs to a whole number. Correct? But see students, 5 minus of 9, what it become? Minus 4. 9 minus of 5 is 4. Bigger number is minus. Therefore minus 4. This not belongs to a whole number. Therefore, the closure property not satisfied under subtractions of a whole number. Okay, this closure property of a whole number is not satisfied under subtraction because of -4 is not a whole number. The resultant number it not become a whole number in the every examples. Okay, that's why. Then integers I will take. So 9 minus of -3, what it become? 9 minus into minus plus. 9 plus 3 it become 12. So 12 is belongs to a what? Integers. Or -5 minus of plus 3. See students, -5. So minus into plus -3. So it become -8. Therefore, it belongs to integers. You can take any examples. So if you are subtract it, if any two of the integers, you will the resultant number it become always integers. Therefore, the closure property of integers is satisfied under subtractions. Understand? Addition is also satisfied and subtraction is also satisfied. A whole number only addition, not subtractions. In rational numbers, so rational numbers we can take any two rational numbers. See, 4 by 5 minus of 1 by 5. So these two are the rational numbers. I will subtract it. So it become denominator or same. Subtract the numerator. 4 minus of 1 is 3. 3 by 5. So 3 by 5 is what? 3 by 5 is what? 3 by 5 is a rational number. Therefore, it belongs to a rational number. Therefore, the closure property of a rational number is satisfied under the subtractions. So you can take any examples. You will subtract it. You will become a rational number only. Therefore, integers and the rational numbers it satisfied under addition and also subtraction. But whole number only addition, not subtractions. So come to the multiplication. So multiplication, see students, I will take one of the example. 5 into 3. 5 is a whole number, 3 is also another whole number. 5 3 is a 15. 15 is belongs to a whole number. Therefore, you can take any examples. You have to multiply, you have to product it of any two whole number. The resultant number is also become a whole number. Therefore, the closure property is satisfied under what? Multiplication of a whole number. And then integers, it is also coming. So -2 into -3. So minus into minus plus, 3 2s are 6. Or -2 into +3, it is equal to -6. So both are what belongs to a integers. You can take any examples of any two integers. You have to multiply it. The resultant number it become a integers. Therefore, closure property of a integers satisfied under what? Multiplication. But here also whole number is also satisfied. Integer is also satisfied. And then rational numbers. Rational numbers 3 by 8 into 2 by 3. 2 1s are 2 4s are 3 3 get cancel, remaining 1 by 4. So 1 by 4 is belongs to a rational numbers. Therefore closure property is satisfied of a rational numbers under multiplications. Here students, whole number is also satisfied, integer is also satisfied, and rational number is also satisfied. The last finally division. Division students, here students, 10 divided by 3 it is equal to 10 divided by 5 it is equal to 5. 10 by 5, 5 ones are 5 2s are, it become 2. So it belongs to a whole number, correct? But 5 divided by 10, so 5 by 10 in the form of 5 by 10, 5 ones are 5 2s are, it is equal to 1 by 2. It not belongs to a whole number. Therefore, the closure property of a whole number does not satisfy under divisions. Okay, because of 1 by 2 is not a whole number. Integers we take. So -6 divided by +3 it is equal to, see students, -6 divided by +3. So minus divided by plus it become minus. 3 ones are 3 2s are. So 2 by 1. So 2 by 1 is a 2. So therefore -2 is what? Integers. But see students, +3 divided by -6. What it happen? -6 divided by, sorry, +3 divided by -6. Plus divided by minus. 3 ones are 3 2s are. It becomes -1 by 2, but not belongs to a integers. Therefore, closure property does not satisfy. Closure property of a integer does not satisfy under divisions. So in the division, the integers, the closure property is not satisfied, and also whole number is also not satisfied. The rational numbers, see, 3 by 10 divided by 6 divided by 5 is there. See students, 3 by 10 into divided by become into 6 by 5 become 5 by 6 because of reciprocal. So as it in the fractions, 5 ones are 5 twos are 3 ones are 3 twos are, it become 1 by 4, but 1 by 4 is a belongs to a rational numbers. So but another example you can take. See students, 3 divided by 0, 3 divided by 0 it will become 3 by 0. Anything by 0 is anything by 0 by anything is 0. Anything by 0 is infinity, correct? Infinity, but infinity is not a rational number. It not defined, not defined. Infinity is nothing but not defined. Therefore, not defined. Therefore, a closure property of a rational numbers, it does not satisfy under division. Okay, students? Yes. See students, the closure property of a whole number over addition is satisfied, integer is also satisfied, and rational number is also satisfied. So addition is satisfied of all rational numbers. Here subtraction is not satisfied of a whole numbers, and then integer is satisfied, multiplication is also satisfied, rational number is also satisfied, and then multiplication, whole number is also satisfied, integer is also satisfied, rational number is also satisfied. But divisions, no one is satisfied. It is also not satisfied, it is also not satisfied, it is also not satisfied. Understands? So you have to practice in your room, you have to learn and study about these properties. It is very easy. Understand? Closure property is very simple. You can take any whole number or integers or rational numbers. You have to add or subtract, multiply or divide. The resultant number, it become the corresponding numbers. Therefore, then the property is satisfied under the given operations. Otherwise, not. Okay, that's all. So next one, commutative property. Yes. Secondly, commutative property. Commutative property. See students, what does mean about commutative property? Again, over addition, subtraction, multiplication, and divisions. So first of all, I will show the whole number, and then integers, and then rational numbers. See students. So what do you mean about the commutative? Commutativity means, see, you can take any two numbers, A and B, of any two number. So A is one of the number and B is the another number. For example, I will take the whole numbers. See, you can add A plus B over the additions in one of the order, and then, or if you have to add in the different order, these two numbers you can add in the different order. A plus B is nothing but B plus A. Are they equal? If it is equal, then the property is satisfied under corresponding operations. Okay, see students. So commutativity means you can take any whole number, you have to add in a different order, in a different order, manner. So then the resultant number is remains same. Therefore, then the property is satisfied under corresponding operations. For example, whole number I will take. Okay, over the addition. Okay, over addition. See, 3 is one of the whole number, 5 is the another whole number. I will add it, 3 plus 5, and the next side have to change the order. 3 plus 5 is nothing but 5 plus 3. So if you add 3 plus 5, it become what? 8. Here 5 plus 3 is also become 8. Both resulting number is remains same. Therefore, the commutative property is satisfied under the addition of a whole number. Okay, like this. So this resulting number is remains same. Okay. Therefore, next I will go to the integers. See, 6 minus of 3. 6 plus 3. Integers. First plus 6, one of the integers. Minus 3 is the another integers. So I will add it. Next, I will change in the order. Minus 3 I will write first, and then plus 6 after I will write. Okay. See students, plus 6 plus into minus minus 3. It is equal to minus 3 plus into plus plus 6. So 6 minus of 3 plus 3. It is equal to minus 3 plus of 6 plus 3. Therefore, this is also satisfied under the additions. So commutative property of integers is satisfied under additions. Whole number is also satisfied and integer is also satisfied. Next, rational numbers. See students, 3 by 8 is one of the rational number and 4 by 8 is another rational numbers. I will add it. So what will you get? And then you have to interchange in the order. So 4 by 8 plus 3 by 8. Okay. See, denominator are equal. So you have to add the numerator. 3 plus 4 it becomes 7. 7 by 8 it is equal to here also 4 plus 3 equals 7. 7 by 8. Therefore, the both resulting numbers it remains same. Therefore, this commutative property of a rational number is satisfied under additions. So, integer, whole number and rational number. So, everyone is satisfied under additions. Come to the subtraction. Subtraction, see students, 9 minus of 4 is one of the 9 is one of the whole number and 4 is another whole number. I will do the subtractions. So, this is one of the order. I will interchange in the order. It becomes 4 minus of 9. 4 you have to write first and 9 have to next. So, first side 9 minus of 4, what is the result? So, it becomes plus 5. Okay. It is equal to here minus 5, but it is not equal. 5 minus of minus 5 is not equal. Therefore, the commutative property of a whole number it does not satisfy under subtractions. Integers, see here, minus 9 plus of minus 4. It is equal to, firstly minus 4 you have to write, sorry, plus not, this is minus, you have to do subtraction. Minus 4 and minus of minus 9. Okay, see, first minus 9 I have to, as it is written, minus into minus plus 4, it is equal to minus 4 as it is written, minus into minus plus 9. So what is the resultant in the LHS set? Minus 9 plus 4, it becomes minus 5. It is equal to minus 4 plus 9, it becomes plus 5. Therefore, the resulting result is not remain same. Therefore, the closure property or commutative property does not satisfy under subtractions of integers. Okay, here minus 9 is minus 4, in minus 4 minus 9. We have to do subtraction. In this resultant minus 5, here plus 5. Therefore, the resulting number is not remain same. Therefore, it is not satisfied. And then next, rational numbers. The rational numbers under the subtraction is it? See students, 3 by 4 minus of 1 by 4. This is one of the rational and this is of another rational. So I will subtract in the different order. So my 1 by 4 you have to write first and minus of 3 by 4 I have to write next. So 4 as it is you have to write on 3 minus of 1 it becomes 2. 2 by 4 it is equal to 4 as it is written. So plus 1 minus of 3 becomes minus 2. So 2 1s are 2 2s are 2 1s are 2 2s are. Therefore it is become 1 by 2 it is equal to minus 1 by 2. Here also not equal. Therefore, what rational number, the commutative property of a rational number, it does not satisfy under the subtractions. Here students, here observe students, whole number is also not satisfied and the integer is also not satisfied and the rational number is also not satisfied. But in the addition, all are satisfied. Subtraction, all are not satisfied. Multiplication also all are satisfied. See. So whole number 3 is the 6 is another one of the whole number. So into 3 is the another whole number. So I will multiply in the another order 3 into 6. But resulting number is remain same. 3 6 are 18. 6 3 are 18. So the resulting number is same. Therefore, the commutative property of a whole number is satisfied under addition. Sorry, multiplication. Like that, integers minus 3 and minus 4. It is equal to minus 4 into minus 3. So minus into minus plus 3 4s are 12. So minus into minus plus 3 4s are 12. Therefore, here also satisfied under multiplication of integers. In the rational numbers, see 3 by 8 into 4 by 5. Here is equal to 4 by 5 into 3 by 8 in a different order. See 4 1s are 4 2s are 4 1s are 4 2s are 3 as it is 2 5s are 10. It is equal to 3 as it is 5 2s are 10. So 3 by 10 is equal to 3 by 10. This is also satisfied under the multiplication. Therefore, the commutative property of a whole number, of integers and the rational number is satisfied under multiplication. Okay. The last finally division. See, division. 3 one of the whole number divided by 6 is another whole number. It is equal to 6 divided by 3. So you have to divide in the different order. So 3 divided by 6 is nothing but 3 by 6. 6 divided by 3 is nothing but 6 by 3. So 3 ones are 3 twos are 3 ones are 3 twos are. It is equal to 1 by 2 is equal to 2 by 1 or 2 is not equal. Therefore, the commutative property of a whole number does not satisfy under division. In integers, minus 3 divided by plus 12, it is equal to plus 12 divided by minus 3. Okay, see, minus 3 divided by plus 12, it is equal to plus 12 divided by minus 3. So 3 ones are 3 fours are. So it is equal to minus 1 by 4. This is minus divided by plus, it become minus. 3 ones are 4. 1 by 4 is the remaining. It is equal to 3 ones are 3 fours are. Plus divided by minus, minus 4 by 1. 4 by 1 is nothing but 4. Here also not equal. Therefore, the commutative property does not satisfy under the division of integers. Finally, quotient, rational numbers. 6 divided by 6 by 8 divided by 3 by 4, it is equal to 3 by 4 divided by 6 by 8. So 6 by 8 into 3 by 4 is nothing but 4 by 3. 4 ones are 4 twos are, 3 ones are 3 twos are, 2 get cancelled, remaining 1. So here next 3 by 4 into 8 by 6. 4 ones are 4 twos are, 2 ones are 2 threes are, 6 divided by 8 and 3 by 4 is nothing but 4 by 3. 4 ones are 4 twos are, 3 ones are 3 twos are, and 2 ones are get cancelled. So next finally 4 ones are 4 twos are, 2 ones are 2 threes are, and then 3 get cancelled, remains same. So I will take another example. 9 by 8 divided by 4 by 5. It is equal to 4 by 5 divided by 9 by 8. See students, 9 by 8 as it is written, divided by is become into 4 by 5 is nothing but 5 by 4. It is equal to 4 by 5 as it is, divided is nothing but into 9 by 8 become 8 by 9. Now, there is no dividing any number. 9 5s are 45, 8 4s are 32. 45 by 32. 4 8s are 32, 5 4s are 45. Therefore not equal. Therefore the commutative property of a rational number does not satisfy under the division. Understand? So dear students, in the addition all are satisfied, in the subtraction no one satisfied, and the multiplication all are satisfied, in the division no one satisfied. It only satisfied under addition and the multiplication, and the subtraction and the division is not satisfied. Understand students? So like this we have to discuss in the properties. So in the next classes, dear students, we have to discuss the associative property and the distributive property. Thank you students.